there, you will see that V means 2. Within the world of R, V and 2 are equivalent. They are two sides of the same coin. They cannot be separated until you unassign that value from the letter V. You can reference now the number 2 with the letter V. So instead of doing 2 plus 5, I can do V plus 5, and it'll still tell me, Tim, that's 7. I know, you can't trick me, Tim. I'm R, I'm smart. You can even divide it by 3, and you'll get a sweet repeating number. And again, the significant figures will differ, but you get something like that, right? It's kind of boring and stupid when it's just the number 2, but let's say that it's a coefficient whereby you're hoping to multiply against one of your variables across all of your observations. You want to keep that constant. Or, for example, it's the result of a complex equation that you built that you want to apply to other figures. And you don't want to remember 3.1214, like all that nonsense. You just assign it to a variable, and R remembers for you. And you just look all that much smarter. So, it doesn't just have to be letters, basic numbers. You can assign, for example, the average age to something called age mean, right? So 73 and 74 will show you that instead of constantly referencing the function mean, my data, $age, you can just assign that to a variable, and all of a sudden you've got a single referenceable thing that will spit out the average value for you. That's hugely useful, okay? Especially when you're working with a variety of data sets. Quite often you're not just working with one data frame like mydata.csv here, but with a bunch of them, right? With sometimes overlapping variable names if you're not designing the data set, or the people who did weren't too conscious about it. And so it's really helpful to do this. You can do it with other things like the average days of the week that people drink, or the average amount that they drink, right? Now, you probably are imagining, Tim, this is a rabbit hole. I can start assigning variables with values and then multiply them by each other and assign that to another value, and then I can just keep doing this until my hair grows gray and I'm Rip Van Winkle and no one respects me. Well, this is true. That's basically what I do for a lot of my time. So let's say we want to get the average number of drinks per week that a student has out of our data set. Well, we can take the average days of the week and the average drinks they have on a given day, multiply those together, and you'll have the average number of drinks per week that a student in our observation has, based on the observation. So this is a data frame-wise operation. This might need a little more explaining. Okay. Has anybody been exposed to matrix algebra? Does that name scare some people?
Yeah. Did you ask if it scares some people?
Matrix algebra scared me when I first heard it. I had nightmares, called my mom. It was awful. Soon realized that it was a human construction. Anyways, your data frame, as we've seen, is a series of rows and columns, right? And so let's say that we want the interaction between two of these columns, right? So we have number of drinks at any given sitting, and that's interesting in and of itself. We have the days that people drink out of the week, that's interesting in and of itself, but we want to get an idea of, okay, if we know this, we can know a function of the two of them. You can create a whole new column based on the interaction between two columns, right? So you can multiply these two and get a new value in a column for all of the observations in your data set, right? So what we just did was append a variable to our data set called week drink, right? And that tells us for each of our students how many drinks they have in a week. One of those is 40. They're local liquor stores, probably really well patronized. But this is now a part of our data set, and we can use that in our analysis, right? So we can look at the values, we can get the average of the values. Oh look, in a given week, the average student drinks about 25 drinks. That's meaningful, that's helpful. That helps us gain insight into the dynamics of college socialization, how people pacify their existential crises, things like that. We can even do histograms on that, and we can even look at the distribution between, height. Looks like we found one this time. Kind of weak, but height seems to have some kind of a correlation with how many drinks someone has in a week. Again, this is totally crap data, I made it up. Did everybody get here? Is anybody confused? Please don't be afraid to speak up.
I am confused.
Yes, tell me why.
I don't know how you got where you got.
Okay, so let's say...
I was writing it down.
No, it's cool, Okay. So let's say in our alternative data set, we have a name, right? And Tim was unfortunate enough to be surveyed for the height, weight, major, days of the week drinking, and amount he drinks. Mm-hmm. And unfortunately, this data is now public, and an entire group of undergraduates knows that Tim drinks too much, right? So we've got a variable here, but Tim drinks about 6 drinks every time he sits down to it, right? But he really only drinks like 2 days out of the week because the rest of the time he's busy teaching Introduction to R sessions, right? In this new column, week drink, we can perform a relationship between these two variables with regards to not only Tim, but Jane, John, anyone else,
Yes,
right?
okay,
And so it's a row-wise operation.
So I totally understand this part of it,
Yeah.
but like, did you already do it?
Yeah,
Okay, so that's what I'm confused about.
Okay, so line 84 is where we made this happen, right? So we took my data week drink.
Okay.
So remember where we make variables? We can also make variables within a data frame. So week drink doesn't exist yet. But what we're doing with this arrow here is we're assigning the interaction of these other 2 columns to it. Okay? So we're telling
I see.
R, does that make sense?
Yes.
Yeah, we're telling R basically take the days of the week, that column, multiply it by the number of drinks, that column, and give me a new column that has the interaction of those 2 variables.
Okay.
And then we can use that for its own purposes.
But it's not giving me any information.
Oh no, that's not good.
So I'm on line 84, right?
Yeah.
And then command enter.
Yeah, oh yeah, you have it, so just hit the next one. Yep, there you go.
Oh, okay. Thank
Perfect.
you.
Cool, okay, we're all set. We have like amazing new data, and we can do stuff with it, we can plot it. So now I'm gonna let you in on a secret as to how this data was made. I didn't go out and conduct an interview of a representative subsample of the political science and legal studies population. I used a random number generator, which is one of the really powerful functions in R. So you can generate not only randomly, but based on a distribution, like normal or Poisson for anyone who's familiar with statistics. If you're not, that's fine. This is just a random sample. So the command, it's really unintuitive. It's going to take some remembering. It's called sample. I'm sorry, bad jokes can end. X is the population from which you're sampling. So in this case, 1 through 1,000. Any number between 1 and 1,000 is fair game, right? The size is how many of those numbers that I want, right? So in this case, I want 100 of the numbers that are between 1 and 1,000. And the really important parameter is replace. If replace is true, every time it takes a number from between 1 and 1,000, it'll store that in your new data object, but it'll put it back in there. And there's a chance it'll take it again. If replace is false, if it takes a number, it keeps it. And there's no chance that it'll take number 99 ever again during the sampling process, right? Maybe the next time you sample, but not this time. This is important when you get into some higher level statistical stuff, but it's important to realize you don't want replace to be true if you just want unique values from the population you're sampling, okay? So in this case, we create a variable called ransamp. You'll learn that you talk Orwellian after you use R for long enough. Ransamp is going to be a random sample of 100 values between 1 and 1,000, and we're not going to replace the values that we sample. So if we hit Control-Enter on row 91, we now have a new variable, which if you were to run the class command that I taught you earlier, would show you that it's a series of integers, which are numbers that we can run statistical analyses on. And it'll show you in the top right there that there's there's 100 of them, 1 to 100, and it'll start listing the values, right? We can highlight that object like this and hit Control-Enter, and it'll show us all of them, but if we sampled a bunch, that might not be too meaningful. So we can just take a quick average and show, oh, it's actually kind of like right between 1 and 1,000. I mean, not perfectly, but that's pretty good. So this may seem a little dumb for the current purposes. First step, did everybody get through that? We all randomly sampled, we've all got something. A quick note, if you run a command called set:seed and you put a variable in there, anyone who runs that command on their computer will get the same results. This is important for reproducibility of your statistical research. So if you're running a random sampling process in something that, because you're all brilliant and you're going to change the world, you're intending on submitting for publication, they're going to say, okay, this is cool, this is great, but I want to be able to do it. And you'll be able to say, okay, well, I set the seed 5165. And if they do that, they'll run a sample, they'll get the same exact values, and they'll be able to replicate your work. Okay? That's not too pertinent for this, but it'll come up later, and I just wanted to let you know. You didn't all get the same variables this time, but if we coordinated, you would have. So, let's get the names of the my data set, because what we're going to do now is basically make our own data sets. This is going to be a whole lot of fun. You're all going to walk away with your own fake data set on college drinking behavior, okay? So, line 95, again, it's a command we learned earlier, listed the names of the original data set that we've been working with. We know that we're getting the ID of the students, the age, the height, the weight, the major, the days they drink, the number of the drink, and the number of drinks they have in a week. we're doing what I told you earlier, setting the seed, number 328. Totally arbitrary, but it's just meant for consistency. You can also make it symbolic if you're into that. Oh, I'm sorry I'm running over, guys. I promise we're right near the end here. And then what you can do, and this is particularly useful when you're running long scripts, is you can highlight a bunch of lines and then just hit Control-Enter and it'll run all of them. But let's just quickly review what it is we're doing here before we do that, because it's going to give you a majestic, bigger data set to work with. And we just want to get an idea of why. So we're creating a value called IDs, 1 through 100. So we're going to create a data set of 100 students. We're going to get their ages. Because these are fake people, we're just going to sample between what would be meaningful values for ages. So on a college campus, you can find someone between 18 and 30. That's almost a given, right? So we're going to get about 100 students. It's fine if we replace in this instance because there's not 100 values between 18 and 30. So feasibly, it couldn't give us 100 values if we put replace equals false. And that's our sampling population. So now we have a new variable called ages. We're going to do the same thing with heights between people who are 52 to 84 inches tall. There are certainly people outside of the distribution, but this is just for simplicity, right? We're going to do replace true for all of these. You can also do this with non-numeric variables. So you can sample from a character string, right? So we introduced a new major in this one. Not only are we studying political scientists and legal studies, but sociologists too, because maybe they don't drink at all, or maybe they're having a way worse time than the rest of us. So we can sample that, and it'll just randomly pluck 1 from the 3 for 100 times. Same thing with days. We really only want 0 through 7, because you can't drink 8 days out of the week, no matter how hard you try. And drinks, we're going to take a conservative estimate as to how messed up everyone's getting and limit it to 12 on a given night. Okay? So, finally, and this is important, this is a command for a data frame that will build the same thing that you read in with mydata.csv. It'll give you a matrix with variable names that we specify there, ID, that correspond to the data objects that you feed it, right? So when I build this data frame, I'm telling it, okay, give me a variable called ID and fill that in with the object I made earlier called IDs, right? So we're gonna, in that column, we're gonna have the numbers 1 through 100. I also want a variable called age, and we're gonna put the ages sample that we put in, right? And it's gonna fill that in. And that's why it's important that we kept 100 across all of these, right? Because the data frame has to have the same number of observations per variable. Otherwise, it won't build you a data frame, right? You can't have a data frame with like 50 rows on one, 100 rows on another. It doesn't work out that way. So as long as these are consistently long, you can build a data frame with as many variables as you want and assign the data objects that you just created to those. So let's highlight these, hit Control-Enter, and hopefully you have an object called myNewData that contains all of these. And you can look at that. Let's click it. All of a sudden, we have a much bigger data frame with information on the ages, heights, weights, majors, days drink, and the number of drinks that these people have. Was anybody unable to generate a new longer data frame?
I thought you'd be able to see it if you created it in yours.
You got it? You got it?
I mean, you have the data.
The set seed was, so like, how do you think a random number generator works?
Actually,
Computers are like, as I understand it, computers are basically preloaded with a series of just a bunch of numbers. And the seed tells it basically where to start, right? And so all computers are working on the same list, basically, of like an infinite distribution of numbers. But the seed tells it, start here, and it'll be the same ones after. 328 is like an arbitrary assignment. It's not going to start at number 328.
You can
right?
don't go to the bottom right-hand corner. If you go there, it's going to hide everything.
Okay, how do
what
I
it
get
does
this
is you could,
I just want to get some.
I think the seed has to be a number, but like you can call it giraffe for all you want, right? Every computer that sees set seed giraffe will say, okay, I'm going to start at this one, right?
So is the idea for that, like, if you
I'm going
want
to
somebody
show
else
the
to do a
first 10
random
rows of the
generator
data. I
with
just
the
don't
same
know
numbers
the
that you randomly
command
generated?
for it.
Yeah,
Okay.
so when you
just copy
publish your
command
seminal
from
work on the
above.
interaction between gender discrepancies and cross-cutting societal ties, and it involves some kind of like a bootstrap resampling that requires this sampling procedure, and you send it off to top journals in the field that immediately accept it, they're going to have to replicate your work, and so they're going to need the seed that you used to set the seed, because otherwise it's impossible to replicate. It's like a 1 in infinite
So
chance that
it's
they'll
like
get
a
the same.
computer, it's like the function that allows you to be able to replicate it so that you
that's
can
your
treat it like a
entire-
hard
On any other machine.
Okay.
Okay, so we all have this new data frame, right? And it's got the same variables that we started with.